Hey guys, welcome back to the channel. Today we're going to install this set of Verus Rear tie rod arms. Should be pretty quick, but actually wanted to discuss the arms before we kind of get into it. So let me see if we can get a close-up shot here and show what we're looking at. Okay, so these are the arms. They're turnbuckle style. So that's probably one of the main reasons why you might get a set of arms like these. The factory rear toe arm is an eccentric. So it's essentially an oval shaped washer that when you turn it pushes the arm in and out. And that's great, except that if you take a hard hit to the tire, that eccentric can slip. So one of the ways to avoid that is to use a turnbuckle style tie rod because it's threaded, and there's no clamp holding down an eccentric to keep your toe setting, right? These are just, you twist them so they lengthen or shorten, and that's how you set your toe. The other thing about stock toe arms is, if you notice on these are monoball ends. The stock arms will be made out of a rubber bushing, and so as the suspension loads up and articulates through corners, those bushings will deflect and your toe will change. With a monoball style rod end, there is no flex to the ball, right? It's metal, and so whatever your toe setting is, it'll stay the same. Now, obviously, it's a multi-link suspension, so as the suspension goes up and down through its travel range, toe will shift, but it won't shift as much because there isn't a rubber bushing to deflect. Only thing to kind of watch out for monoballs is that they can wear out over time when dirt gets in between the ball and the race, and it's a really tight tolerance fit, and as that ball loosens over time, it'll get to the point where this ball will rattle around and you want to replace the monoball at that point. But rod ends like these, they're relatively cheap, maybe 20-30 bucks. The nice part with the Verus is that they use some high quality rod ends from FK. FK is a really good rod end. I'd say it's on par with Aurora, not the mil spec stuff, but the commercial stuff. But there's a ton of different brands of rod ends out there, like QA1, Aurora, NMB I think is another one, which is super expensive. Let's see here. They use on the Verus ones, they use two separate types of rod ends. So I think this is stainless steel for rod end on this side, and this is an aluminum one on this side. If you look at the SPL arms, which are very similar to these, I think they use higher grade monoball or rod end. I don't know why Verus chose this one. I mean, there's a chance that these are stronger, but I don't think so. This stainless steel side, that'll put up with water a lot better, but everything's plated for corrosion resistance. And then there's some arguments to be said that you don't want the monoball to be too strong, because in an accident you want the monoball to break versus have it withstand the impact and transmit that force into the subframe and bend the subframe. So I'm not sure. Maybe this was just a cost decision, or it could have been, you know, that kind of like save your parts or save your subframe in case of an accident. And in case of an accident decision, I'm not sure. The other thing about these tie rod adjust turnbuckles or whatever you want to call them, they specifically say don't place a load or don't place it in bind, and that is important. So when you're aligning the car, or when the tech is aligning the car, as you change camber, you will change toe, and the last thing you want to do is bind this up. So that's why I like these adjusters. Last note, they use 10.9 hardware, and these are eccentric lockouts. So I believe the hole is a little bit of an oblong shape, and this will fill it up. There's different styles of lockouts, but essentially they all kind of do the same thing. So let's get to jacking the car up. removing the stock tie rods and putting these in. All right, so tires off, car's up, got the jack stands on, and we're looking at the tie rod. So in case you guys don't know where the tie rod is, it comes up to bolts to the front of the knuckle here. This is the knuckle, this is the tie rod, and this is the kind of eccentric that you'll be adjusting on a factory arm. And what that'll do is the arm is clearly a fixed length, so when you turn the eccentric, it'll pull or push the arm in and out, and that'll change the toe as it pushes and pulls on the knuckle. So the first thing we want to do is remove the factory toe arm, and I'm going to start on this side because this is pretty easy, and the most challenging part of this is going to be the knuckle. It's kind of like a swedge fit, or it's a tight fit or interference fit. So you kind of have to press the stud out or the tie rod out. The first thing you want to do is remove this clip. Easy enough. And then we need to find the right size socket. I'm going to guess 17? 17. So the impact is off, or nuts off. 17, use the impact, that was easy. And as you can see here, it's stuck on there pretty good. So I'm going to use this little 3-prong tool here. Same thing we used to install, to remove wheel studs. This is actually what this tool is supposed to be used for, is tie rods. This kind of like thumb part of the 3-prong tool is going to go on the end of the stud, and this is going to go on the bottom, on the other side of the knuckle. And what we're going to do is as we tighten it down, this little prong will push down and press out the tie rod. So I'm going to slide that under here. Make sure it's on there good. Come on. Yep. There are other places that'll sell you like a pickle fork, and those will work too, but they tend to be a lot harder to use, and they also tend to tear up your boots on your tie rods. Now we're not reusing these tie rods, so I don't really care about tearing the boots, but if you are, I think this tool is a better way to go. Just slipped off. There we go. All right, now let's get the inboard side. Inboard's a 19. Okay, so this is the factory eccentric. This is kind of the oblong shape that I was talking about, so as you turn it, it pushes or draws the arm back in. Let me get this arm off here real quick. It's stuck on the e-brake cable. What is that? Probably a 10. So there's a bracket from the stock arm, holding it onto the e-brake cable. Uses a 12mm bolt. There we go. And So this is our factory tow arm. This is the kind of eccentric hardware here. So unlike the control arm bolt in the front that actually has like an oblong shape to it, this is a standard shape bolt, but it has these washers that as you spin them, there's little tabs on the subframe, and it pushes against the tab and either pulls in the arm or pushes out the arm, and that changes tows. Because of this side-to-side motion, the hole in the subframe is not round, it's an oblong shape. So I'll position the camera here so you can see what I'm talking about. The other thing to note is that the bolt is keyed for these little washers. Okay, so I can't get the camera underneath the car, so we're kind of shooting through the brake. And that is actually the hole right there, dead center of the screen. That is the kind of oblong hole that is there to let the arm go in and out. What we need to do when we are installing aftermarket tow arms is lock out that hole so that the aftermarket arm doesn't move. So Verus has machined this beautiful piece here, this lockout piece that is oblong shaped. So it'll drop into the hole and keep the arm from moving side to side. That way all we have to do when we adjust tow is turn the turnbuckle, and it should make setting the tow much easier and hold it much tighter. So again, there's the hole, and this is our lockout piece. So I'm going to go ahead and bolt up the new tow arm right now. First thing I'm going to do is install the inboard side of the arm, and I'm going to make sure that my arm is in its shortest possible position. Okay. Slip in my lockouts. Boom. Boom. All right, there we go. Whoopsies. Actually, I'm going to slide in the outboard side of the arm first, which you guys aren't going to see, but essentially all I've done is just slip the rod in to the knuckle, and then I will adjust and lengthen the arm by turning the turnbuckle. Sweet. Let's see if that's going to be enough here. Whoops. What I've done is I've installed the nut on the knuckle side, so that way I don't have to hold the tie rod up. Okay. Come on, find the hole. That's it. All right, so the arm's in. I'm gonna draw the stud into the knuckle with an impact here. And that is pretty much how you install an aftermarket tow arm. Pretty easy. So what I'm now going to do is the jam nuts I'm not too worried about for now. Just I'll make them snug. I'm going to torque down this bolt, the knuckle bolt, and the bolt that's on the subframe down a spec, because I'm not going to be playing with those when I do the alignment next. So it just makes sense to do it now. So let me go look those up and we'll torque those down. All right, guys, the car is actually up on the alignment rig now, and it's actually been a week since the first half of the video, and I've actually got a cold, so if I sound a little bit different, I apologize. Before we align anything, you know, one of the things I kind of felt was wrong were the torque specs. As I was torquing down that inboard bolt, it just felt funny, and so unfortunately the arms didn't come with any instructions. So before leaving it as is and just calling it a day, I actually gave Verus a phone call, and they were quick to pick up, and I verified with Clay and Paul. The torque spec on that inboard bolt is actually 44 foot-pounds, significantly less than the stock 74 foot-pounds. And that's a 3.5 inch diameter bolt, grade 8, and that's way over the torque spec for that bolt. So more than anything, that bolt is torqued to failure or almost about to fail, and so we cannot have that happen while we're on the track. So what I've done is, after a lot of back and forth, I found new bolts, also grade 8, and we're going to torque them down correctly. Additionally, this bolt also needs to be torqued to 44 foot-pounds, not the 66.5, but that's stainless steel, so I think, and it's pretty big diameter, so I think 66.5 is actually okay. And then this bolt needs to be torqued to 44 foot-pounds. So I'm going to go ahead and do that right now. I will also make a note in the first half of the video so no one makes this same mistake. It is important to always double check torque specs, because bolts and fasteners do have failure points if you go over their specs. And in this case, we got lucky, we caught it beforehand. So if you are getting a bolt that's smaller in diameter, definitely double check with the manufacturer. So I will go ahead and remove that inboard mount, make sure everything's okay, and then retorque everything to spec. Okay, so everything's torqued. Now I'm going to go ahead and do the other side, and then we can get to lining the car. All right, so other side's done. The last thing I wanted to touch on here was on the inboard side of your rear tie rod or lateral link, the e-brake cable bolts up to it. I just used a zip tie, and there's like a hole in the subframe above where you mount the tie rod, and I just zip tied it to that, as you can see here. The other thing to note is, so I think previously in the video, which I don't remember now because it was a week ago, I talked about tie rod binding, and I was talking about the turnbuckle being tight. Thought about that some more and then verified it with Verus. That's incorrect. The binding is referring to the monoball. Hang on here. So the binding is referring to the monoball. So it is a rod end, kind of like this. There's a ball inside of this end, and that ball moves around. This one's really tight, so I can't move it. I don't think you really have to be concerned with the inboard one, because as you raise and lower the car, it rotates in line with the monoball. But this is the one you got to be worried about. If you lower the car too much, what'll happen is you'll max out the angle that the ball can rotate in, and once you max it out, you're now loading that rod end in a way that it was never designed to do, and it will fail. So here, let me show you really quick on a rod end that I have. Okay guys, so this is a rod end that I'm using for the sway bar. but the idea is the same. So imagine this is your outboard rod end. This would be your male, and this goes into the turnbuckle, and then this would be your turnbuckle. What they're referring to by binding the monoball is this is the ball, this is the race, and the ball moves inside of the race, if you can see that right there. Sorry, I have to hold it really tight, so because it's got a really tight tolerances. So it moves inside the race, right? So this is kind of like center, and if the car goes up or you raise the car, the subframe goes up, and the monoball will do that. And then if you lower the car, the monoball will do that, because this is the inboard side and this is the outboard side. Ideally, you want to be somewhere in the middle of the articulation range of the ball. That way, as you go over bumps and the suspension goes up and down, the ball moves kind of inside of its range of motion, right? If you lower the car too much, and at static ride height, your ball's maxed out, it's doing that, right? What'll happen is, if the suspension compresses even more, the ball cannot articulate. And now you're loading up the race, you're loading up that rod end in a way it was never designed to take, and it can fail. So you don't want this to happen. So just keep an eye out that when you do install these, your ball is roughly in the center of the race when the car is sitting under its own weight at its ride height. I don't think you have to worry about the inboard mount. You really got to worry about the outboard monoball, because that's the one that's going to be articulating like this, right? And you do want to be roughly in the center. If you're maxed out in any direction when the car is sitting at its static ride height, you have a problem. All right. So hopefully that covers it. As always, guys, thank you very much for watching. If you guys have any questions, don't hesitate to ask in the comment section. And as always, we'll see you at the next video. Take care. Bye.